Hello, everybody. My name is Felix Rogotsky, and this is the presentation about stars and their life, which also includes our sun, as you know. So, here are some of the main sun concepts that you need to know. So, to be fair, the sun is a pretty average star. And the only reason why the sun is so bright is because it's pretty close to the Earth compared to some of the other planets in our solar system. At a distance of 93 million miles, it's about 250,000 times closer than the next closest star to us. And yeah, and just like humans, stars have life cycles, and their life cycle usually depends on how massive they are. Yeah. And stars like the sun are incredibly important to the Earth. Like the sun is incredibly important to the Earth, and it provides all of our heat and light. And actually, it even is the reason why we have winds on Earth. So yeah, the sun's pretty important. As shown in this figure, the sun is very impressively large. The diameter of the sun is about 109 times of the diameter of the Earth. And it actually has a mass 330,000 times greater than the Earth's mass. The figure also shows the sun in comparison to Jupiter, which is the largest planet in our solar system. The sun is an average star, as you can see here. Yeah. So in this image, which this image is pretty bad, however, it you can still see that you can barely see that Jupiter is about 1 pixel in size when you compare it to the sun right here. And Earth is pretty much invisible at this scale because the sun is pretty big compared to the Earth. And how do stars work? Stars must have an energy source to shine. For example, they need nuclear fusion. And really, actually, nuclear fusion's the the way stars shine. I mean, without nuclear fusion, no star would work. And it basically combines small atoms into larger atoms under extreme heat and pressure. And this process releases energy. The energy generated in the core of the star flows outwards toward the surface. And this outward flow of energy and the inward pull of gravity is actually a balance, and that's what keeps the star stable. And these two forces determine the stages of a star's life throughout its life. Stars are born in giant clouds of gas in deep space. Gravity causes these gases to actually clump together, which causes them to eventually collapse. And then when the temperature is enough for nuclear fusion, then the star is born. The star starts doing star stuff like nuclear fusion. And this big star forming cloud named the Orion Nebula is was actually taken this picture was taken by the Hubble telescope, and the telescope is pretty big, and we took this picture. And here's the life cycle of stars. So first they go from a stellar nebula, which are the gas clouds, to your average star like our sun. And then eventually our sun's going to become a red giant. Then all of its outer layers will be shed in a planetary nebula, and then that will go away, and our sun will become a white dwarf. However, for stars bigger than our sun, like a lot bigger, they go into a red supergiant phase, which is the same thing as the red giant phase, but bigger. And then a supernova happens. And a supernova is basically a massive explosion where the entire star's contents bounce off of the core of the star. And two things can happen after a supernova. If the star was massive enough, it can turn into a black hole, or if a star is not at that critical threshold, it becomes a neutron star. And energy released from the nuclear fusion of hydrogen balances stars against gravity. But the hydrogen eventually runs out, and this is when the star starts to collapse. And the end of low mass stars. Red giant expels outer layers of gas, and these images were also taken by the Hubble Space Telescope. And this is basically how low mass stars pretty much die. They turn into white dwarfs. Yeah, low mass stars end as white dwarfs, and they're actually about the size of a planet because they're dead cores of the star. And a supernova is when a really massive star, iron builds up in its core, which is eventually what happens in the star's life cycle. When then the entire core is converted into iron. Energy generation stops since fusing iron doesn't release energy anymore. Then the core of the star collapses under gravity. After the collapse, the core bounces and the bounce blows the star apart in a spectacular explosion known as a supernova. This graphic picture shows a supernova in 1987. The right-hand side picture is taken before the explosion, and the left-hand picture was taken shortly after the explosion. Supernovae are very bright and can briefly outshine the galaxy that they are in. All right, these are images of remains of a supernova, and they actually exploded 300 years ago. And yeah, the X-ray image shows hot gases that happen with the supernova explosion. And what's left after the supernova? Well, the supernova doesn't completely blow the star apart, as I have said. The core collapses to a very compact object. Like, for example, a neutron star. See, if the original star was less than 20 times the was 20 solar masses, which is basically one solar mass is the mass of one sun. Protons and neutrons combine to form neutrons, and they're actually so dense that pretty much the entire core of the star, is only 10 kilometers across. And a black hole forms if the original star is greater than 20 solar masses. And not even compacted neutrons can support the weight of such massive stars, so they just turn into a black hole. All right, that's the end. I hope you enjoyed this presentation. And now I will get to something that I have to show you. All right. There's this game called Universe Sandbox, and it's supposed to simulate space, and I'm gonna show you what you can actually do with stars. Yeah. I'm about to launch the game very soon, and you're all gonna see Universe Sandbox and how it works. Right, if you just give me a second. All right, so this is a simulation. All right, this is the simulation. This is Universe Sandbox, and as you can see here, this is the solar system, all right? And in this game, what you can do is you can actually simulate what would happen in the solar system. Or if you'd want to, you can also make a new empty simulation and put solar objects in. So for example, we have the sun. Now the sun is normal for now, but if you'd want to, you can simulate what would happen if the sun was twice as massive while retaining the same radius. Now you can see here that increase the mass of the sun twice, the orbits of the planets start to get a little wonky since gravity has a larger effect on them. And you can actually see that pretty much everything that's close to the solar system is being pulled in due to the sun's larger gravity. And yeah, you can also do stuff like increase its density, and increasing its density will also increasing its density will actually reduce its radius, although it should, because, well, the sun is denser and its mass is twice the sun, which I already said. So in theory, the radius should grow smaller. Oh yeah, you can also click on the individual planets and you can see what's happening to them. So for example, being closer to the sun, Mercury is heating up quite a bit because of the orbit. Yeah. There's also some other cool things you can do with stars. Like for example, if I click the tools button right here and I do explode, I can make the sun explode. But before I do that, you can slow down time to around like minutes per second, for example. Like before I was gonna blow up the sun, my time was in days per second, which meant that amount of days would happen per real second. I'm gonna slow it down so you can better see what would happen to the entire solar system if the sun exploded right now. And keep in mind that this is a what would happen if the sun became a supernova, meaning that the sun wouldn't normally become a supernova. However, all it would do is, however, in real life, it would become a planetary nebula, obviously. But we can make suns supernova. We can make things like the sun supernova in this game. So right now, the Earth is kind of hot because its orbit was changed. And now let's see what would happen to Earth if the sun exploded. So right now you can see the supernova expanding outwards. And really, let me get a good perspective right here. Yeah, and you can zoom out and you can actually see how the supernova expands as if this were a star that can supernova. Let me speed up time so you can see what happens. And if we actually look at Mercury seems rather unaffected by the supernova. However, Earth might be a bit of a different story. Right now I have it set to 3 minutes per second. So like several minutes, so like after like an hour or so, Earth would be completely engulfed by the supernova if it hit. However, keep in mind that the Earth's orbit was changed, so this isn't, yeah. Yeah, let me zoom into the I'm gonna zoom into the Earth to see what happened to the Earth. So right now you can see that the Earth is getting really, really hot. Yeah, it's heating up right now. Yeah, see, this is what would happen to the Earth if a supernova hit it, and the supernova happened close to the Earth. Half of the Earth would heat up to 5,000 to an average temperature of 6,000 degrees Celsius and rising. Oh, and there's also a surface tab right here, which allows us to visually see the surface of the Earth and where the temperature is concentrated. Like for example, the region of Earth where the supernova is hitting is 20,000 Celsius, and it's like right here. However, this area right here is still pretty hot. It's still like 273 Celsius, which is still too hot for humans to live, but it's still incredibly hot due to the supernova. All right, I'm gonna load in a new simulation, and this will show off some of the other cool features you can do with stars in this game. All right, so you can actually add any objects you want to the simulation. Like for example, you can add the sun. Yeah, we already seen the sun though, so I don't we don't. I'm gonna add something else. Like, all right, I'm gonna add in WY Canis Majors now. Now, this isn't the official name, but pretty much this is a massive supergiant, or it's a supergiant star, and as we can see, it's 6 times the mass of our sun. Its mass is actually 17 times our sun, but its radius is about 6 times our is about 6 astronomical units, which is the distance from the Earth to the sun, and its luminosity is about 270,000 times more than our sun. So you can see that its speed is 0 meters per second because it's not moving anywhere for now because I made it still. But we can change the speed and all of that. Yeah. Can also see the composition, and since this is a star, its composition is going to be hydrogen 100%, because as we said, this star converts hydrogen to helium. Now, helium isn't really represented in this game for some reason, or other fusion elements, but yeah, you can also you can also put stars, or you can put planets in orbit around the sun. So if we had Earth orbiting this star at like around 20 astronomical units, we can actually see what would happen to the Earth. So so you can already see that the Earth is starting to heat up due to it being really close to the star. And yeah, you can see that. You can see that visualized. You can look at its surface temperature. Let's actually watch the surface temperature of this of Earth right now. And it's increasing. All right, I'm gonna delete the Earth because this isn't about Earth. This is supposed to be about like the things you can do with stars. So you can also have stars orbit each other in this game, which is actually kind of cool. So if we take Betelgeuse for a second, which is also another star that's larger than Earth, or the sun. If we speed up time, we can actually see the oh wait, hold on, I did it wrong. But the point being, if you set it to be in binary orbit, you can actually make stars orbit each other. Oh wait, actually, yeah, see, stars can actually orbit like this, which will cause them to orbit each other like this, and they can also collide, and that's probably not going to happen here, but if when stars collide, they will also supernova. Yeah, I'll show that next. So, yeah, yeah, so You can see its speed is around 27 kilometers per second, which is how the star is orbiting around this. And yeah, you can also change, you can change stuff about the stars too. Like you can change their name to like star, and you can also change their temperature, which will cause them to change colors. Like for example, I changed the temperature of Betelgeuse to like 10 times what it originally was. And this causes it to turn blue because temperature changes the light of a star. Yeah. Yeah. And age doesn't really affect anything of the star. I mean, it should. Like this star should like be long blown up by now and supernovaed. And yeah, that's all I really have to say about stars in Universe Sandbox. So that's it. All right. I hope you enjoyed watching me talk about stars and showing off Universe Sandbox. All right. So, yep, that's it. Yep, we're at the end. So, any questions? All right, guys, thank you for your time. This webinar will be available in the past event section on our website. And if you are interested to know more about Universe Sandbox, please submit a tutoring request via contact form on our website. All right, that's it. All right.